Hey team, Mr. Munro here with another AO, this time AO7, solving equations with variables on both sides. Now this is one of my favorite ones to do, and the reason it's one of my favorite is because I get to talk about Kung Fu. Hence the reason for the Jackie Chan on the right hand side here. Now we've talked about the Jackie Chan style of solving algebra before. For a little recap on that, have a look back at AO2 where we looked at solving two-step linear equations. But today we're looking at equations that have variables on both sides. As an example, you can see our equation here. There's an x on the left and an x on the right of the equal sign. So what we're doing is we're trying to solve to figure out what that value of x actually is. Remember, when we're solving, we're actually going to get a value for that unknown, for that x value in this case. And those variables are obviously our x's. So that's just a little breakdown of what that AO actually means. Now, recap on our Jackie Chan style of solving algebra in a moment, but before we do that, I just want to talk about this guy here, our equal sign. Now, we often misinterpret what the equal sign means in maths. We often assume that it means this is where the answer needs to go, such as 1 plus 2, now put the answer. But what the equal sign actually means is the equal sign is sort of like a scale, it's a balance. What it's saying is whatever is on this side of the equal sign is equal to whatever is on the other side of the equal sign. This must be equal to that. So 1 plus 2 is 3, which is equal to 3, which is on the side of the equal sign. Or you could say 1 plus 2 is equal to 4 minus 1. That makes sense because this is 3 and this is 3 as well. So that's what we're saying here when we're looking at equations with variables on both sides. What we're saying is whatever is here is the same value as whatever is here. So let's have a look at this visually first, all right? So here we have two x's, and we've got 3 dots, and here we've got 1x and 5 dots, just like our equation up above. So what I want to do is I'm just going to remove some bits to see if I can figure out exactly what the value of x is. So let's start with this. There are 3 dots here on this side here. There are 5 dots on this side, but I'm just going to remove 3 of them to begin with. I'm just going to take them off the scale. 1, 2, 3. Fantastic. So now I'm left with 2 x's over here, an x here, 2 dots there. Right. Now I'm going to take 1x off each side of the scale. Let's take 1 off there. Let's take 1 off there. Which means x has to equal 2. Because we've taken balanced amounts off each side, we're left with just x and 2. Let's have a look at how this plays out in terms of actual algebraic formulae, actual algebraic solving. So our Jackie Chan style of algebra follows this process. First thing we have to do is we have to pick who are we going to take out first? Which of the henchmen are we going to deal with first? Who is the weakest link? Our second move is our counterattack. What is the perfect counterattack in order to take out that specific value that we selected in the previous step? Once we've done that counterattack, we need to maintain balance. Wax on, wax off. Right? Kung Fu is all about balance, so whatever we do to one side, we have to do to the other side as well. And then once we have maintained that balance, we then reassess. We rewrite the equation to make sure that we know what's going on next, who we're going to deal with next. So let's attempt it with this. First, I'm going to pick someone to pick on. Now, I've got x's on both sides and I've got numbers on both sides. So what I'm going to do is I'm going to start with the x's. All right, so I'm going to start with this guy here. Now, he's a plus x, remember? So what I'm going to do in order to get rid of him is I'm going to subtract an x. All right. So I've picked my person. I have gone with the counterattack. I need to make sure I maintain balance. So whatever I do to this side here, I have to do to this side here as well. So I'm going to take x away from here too. And now I reassess. I'm going to rewrite my equation so I know exactly where I'm at. So I've taken an x off there, so I'm now at 1x. Still got the 3. I've taken the x off there, which means I'm just left with 5. Fantastic. All right, now what's my next step? Now I'm going to take out the weakest of these two. I'm going to take out this guy here. Take out this one here. Right, he is a +3, so how am I going to get rid of him? -3. That's going to be his counterattack. Got to do the same over here to maintain balance. Means I'm left with just x over here and 2 over there, right? Just like we had before. Fantastic. So let's go through and try a couple more, see if we can really get our head around this. So that's our process. Just to remind ourselves, our process is first, pick out who we're going to pick on. Figure out who we're going to take out first. We're going to use the counterattack in order to take them out. We need to make sure we maintain balance. That wax on, wax off. And once we've maintained balance, we need to make sure we reassess so that we don't get ourselves muddled up. So we can rewrite the equation. This step here, step 4, is an often underrated step by a lot of people. There's this incorrect assumption that writing less makes you a better mathematician. By removing steps, by writing less, that doesn't make you wiser. That's getting the wrong end of the stick. When you've practiced a lot, you can leave out steps, but you can't leave out steps in order to just get better. It's not the way it works. It's getting the wrong end of the stick there. So when you're starting off with this, it's really important to write all those steps. As you get more capable, you don't need all those steps. You no longer need them, but you need them to start off with. Just keep writing them in until you really, really get your head around this sort of stuff. So in this case, I'm just going to write all of the steps out so you can see and so you can follow what's going on. So you can get in those really good habits as well. All right, let's start with this guy. Let's go over here. Right, so first step, I'm going to pick on. Who am I going to pick on? I'm going to pick on this guy first, I think. Pick on this guy here, and the reason I'm picking on him is just because he's the lowest of the x's. I'm going to pick on him first. Right, so let's eliminate him. We are going to minus 3x from this side. Means I'm going to minus 3x from this side. I'm going to rewrite this out now. That's been eliminated, so I'm left with just 3 on this side. And I've lost 1x. I've lost 3 x's from there, so I'm left with just 1x there and still the minus 1. Brilliant. So I've picked, I've counterattacked, I've balanced, and I've reassessed. Okay. My next step that I'm going to do. I'm going to take this guy here out now. He's a -1. So what's his counterattack be? Well, his counterattack is going to be a +1, right? So if I +1 to him, I have to +1 over here as well. Let's go through and rewrite it out. 4 equals x. X equals 4. Right. So we've figured out what the value of x is. Now, a really good habit to get into when you're starting off is to actually just go through and check one of your equations. Students will often say to me, is my answer correct? Well, I'll often say to them and respond, I don't know, is your answer correct? Because you can actually just put back in, you can just substitute back into the initial equation to see whether it is correct or not. So let's do that. We've said that we've said that x is 4. So if it is, then it should end up being equal. Let's do this. X is 4, so 3 times 4 plus 3 equals 4 times 4 minus 1. So 3 times 4 is 12 plus 3, that's 15. 4 times 4 is 16 minus 1, and 16 minus 1 is 15 as well. So yeah, they are equal. Right, so we've got our answer correct. So it's a good little habit to go back into, using one of those skills that we've looked at previously. That substituting into the formula, it's AO5. Going back and using that to check if we're not sure, especially really handy when you're starting off. All right, let's move on now. Let's have a look at our second question here. 4x plus 25 equals 7x plus 4. Okay, so let's start. I'm going to take this guy here out. I just like to take the x's out to begin with, so I'm dealing with, less x's. So I'm going to take 4x off there. So I'm going to take 4x off there. Let's rewrite this. 25 equals 3x plus 4. Okay, so I'm going to take 4 off there now. Let's do that. So I'm going to take 4 off there as well. So that's going to be 21 equals 3x. That's eliminated that. Fantastic. And I've got one last step. That's times by 3, so I need to divide that by 3. Which means I need to divide that by 3. And 21 divided by 3 is 7 equals x. So x equals 7. There we go. So now's your opportunity to try a couple of questions on your own. Before you do that, remember our process is first, figure out who you're going to pick on. 2, counterattack. Whoever you're picking on, whoever that henchman is, you're using the ultimate counterattack. If it's a plus 4, you're going with a minus 4. If it's times by 3, you're going with a divide by 3. You need to maintain balance next. So whatever you've done to one side, you have to do to the other side as well. Wax on, wax off. And after that, you need to reassess. Rewrite your equation out underneath after you've eliminated, after you've maintained balance. So you know what you can do next. Okay, so here are your two questions. 5x plus 20 equals 8x plus 5, and x plus 9 equals 5x minus 7. All right, give them a shot. Okay, how'd you do? Let's give these a shot. See how we go. Remember, if you really struggle with that, you can always just pause the video or rewind the video, go back to the start, have a look again. But I'm going to assume you paused the video and you think you're on the right track. So let's give it a shot. Where are we going to start with over here? Okay, so I'm going to start this. I'm going to take that away, which means I'm going to take 5x away from there as well. So it's going to leave me with 20 there, and it's going to leave me with 3x plus 5 over here. Okay, next step, take 5 away from there, which means I'm going to take 5 away from there. That leaves me with 15 over here and 3x there. Now, next step, and I can probably solve it from here, but anyway, let's go through and do it. That's times by 3, so I'm going to divide by 3 there, divide that by 3, which means I'm left with 5 equals x. 5 equals x. There's my first answer. Hopefully you got the same thing as well. And next, all right, let's take this guy here out first. So subtract 1 away from there. So that's 9 equals 4x minus 7. Let's deal with this guy next. I'm going to add 7. That leaves me with 16 equals 4x. Now I'm going to divide that by 4. I'm going to divide that by 4, which means 4 equals x. So my answer is x. All right, so hopefully you were able to get the right answer on both of those, and hopefully you check them yourselves as well before you continue the video by substituting them back into the formula. If you struggle with that, like I said, go back through, rewatch the video. You can even go back and rewatch some of the other videos that I've done during this series as well. If you were able to do that, fantastic, well done. That is awesome to see. So that was AO7 solving equations with variables on both sides. Hope you enjoyed that. Hope you learned something, and I hope you're ready for the next challenge. Well done, team.